My name is Tina Aspey, and for those who haven't met me, I'm a project coordinator at FAHMA Group. For producers in this region, the delicate balance between frost and heat is an ongoing area of research. GDERC is supporting FAHMA Group with this research through the RiskWi project. Over the next 5 years, we have funding to navigate this crucial question and work with other researchers in the field. The Frost and Heat Management Analytics Project, otherwise known as FAHMA, is also funded by GRDC. It has the goal of bringing ag tech tools to growers. The lead scientists on this project are joining us today, and I'll let them fill in on the details. We'll be joined a little later by Dr. Julian Lilly. She's the lead scientist on the FAHMA project. She has 30 years of experience as a crop scientist at CSIRO. She uses crop, pasture and livestock models in farming systems to support research. Her research has included dual-purpose cropping, canola productivity and phenology, climate change impacts, crop water use efficiency, whole farm productivity and resource protection. And Dr. David Deary, thanks David, is a senior research scientist on the FAHMA project. His background is in digital architecture. From 2010 to 2020, he played a leading role in a project that developed ways to use remote sensing and big data to improve plant breeding. The potential of big data to support agricultural research is a rapidly emerging field, and this is what David is bringing to the FAHMA project. Next, I'm hoping everybody could introduce themselves and just quickly explain their interest in the Frost and Heat Management Project, if they could. I'm going to get our host, Caitlin, to go first. If you could, Caitlin, thanks.
Morning. So I'm Caitlin Anderson. I'm a project coordinator at FAHMA. So I'm a part of the RiskWi team and the project. So I'm sort of here to see what I guess you guys would like to see in the frost and heat space and how we can better support you in that sort of decision-making tree that you guys go through. So that's why I'm here today.
All right, I'll just nominate people. Brent, Brenton, could you introduce yourself?
Are you talking to me too?
Yes, thanks.
Yeah, sorry. If I'm coming, yeah, just a farmer, bit of east of Wickerpin, so I'm out Jataning way, and frost is a big risk. You spend a lot of money on your crops at those seasons, and it all falls in a heap. So I'd any research in how to mitigate it and what to do after a frost event to be able to tell how much damage we have is what I'm interested in.
Claire, if you could introduce yourself, thanks.
Morning, I'm Claire. I'm also a project coordinator at FAHMA Group. Just here to get some background on what the project will be about and how we can support farmers and hearing from farmers' perspectives on their issues with frost and heat.
Andrew's iPhone, if you could introduce yourself, thanks.
Hi there, I'm Andrew Grieve, farm just east of Cuballing. Well, generally, most years we have a little bit of frost, but I remember 2012, we lost 430 hectares to frost. We ended up baling up 400 hectares, kept about 30 hectares, and we got 3 tonne of chicken feed off it. So it was a total stem frost, and it was sown probably late June and late May to the beginning of June, and it was into canola stubble straight in, it was a west facing crop. It was high and down to creek line areas, but it was totally frosted. And I'm hoping not to go through that again. We've taken steps to try and avoid it again, but yeah, generally during subsequent years, generally there is frost quite often in our area. So trying to learn other ways of avoiding that frost risk.
Thanks for sharing that story, Andrew. I really appreciate that. John Hicks, if you could
Yes,
introduce
good morning. I was a farmer at Pingrup until I retired in 2004. In 1998, we were absolutely smashed with the extensive frost that occurred that year, and I attended our worst crop. We stripped 8 tons of wheat of 120 hectares, and it really put us behind. Then 1999, we had another bad frost. I attended the frost panic meeting in Hyden in 1998, and Dale Baker, the then chairman of the Western Panel of GRDC, told us that
Sorry, John, your connection's gone a bit glitchy there. We'll just move on. For anyone who doesn't know you, Gary, if you could introduce yourself.
That involves unmuting myself. So Gary Lang, farmer, soon to join John Hicks in the retired farmer space. From Wickerton, had a long history with frost and the National Frost Initiative at GRDC, done a lot of frost research, and now on the Western Panel of GRDC.
Thanks, Gary. And then I think we've got Craig.
Which one is couple on there?
Oh, is there? Yep.
I think so. I heard another name, Craig.
Yeah, we'll just start with you, Craig, then.
Yeah, g'day everyone. Craig White. I'm from Bayer. I did work back in the Department of Agriculture way back, and John Hicks was taking me down a trip to memory lane. I was working on frost at the time, mostly around identification and what you can do after the frost. So I was in Merredin at the time in those 98, 99 ones that he referred to. And yeah, a lot of years since then, I'm an agronomist and researcher at Bayer, but just recently moved into digital integration across Australia and New Zealand for Bayer. So I'm just keen to see where the space has come to, how much has changed, and yeah, if there's anything that sort of sits in the general realm of progress and yeah, where it may intersect with what we do, because obviously, you know, growing crops and keep growing them is what it's all about.
Thanks so much, Craig. You're right, we do have another Craig. Mr. Jesperson, if you could introduce yourself.
Yep, sorry my camera's not working. Yeah, Craig Jesperson. I farm at Yellering and Wickerton. Yeah, we've had plenty of frost in the 30 years I've been home. Spent a lot of time, some of those years, walking, riding motorbikes, trying to work out where to cut and where not to cut, or whether it's worth cutting or not. And yeah, it can be quite a difficult decision to make. Then you hop in the cutter and you're trying to work out where to go and where not to go. And yeah, if there's, I'm sort of looking for any tools and that, so when we do have those frosts, any way of being able to map those areas better. I found a drone back in 2016. I think we had the bad frost was an excuse to buy a drone, and that made it much easier to find where to go to cut areas that were badly frosted. Yeah, so if there's any other tools that we can help to make those decisions, yeah, because I found seed dates and that we just spread our risk. We lose, as Gary said, we reckon we lose 20% every year, even if we don't have a frost, through not seeding early because of trying to spread our risk by not putting all our eggs in one basket. But we've had crops that have been sown from the beginning of May to the middle of June. Remember 2012, I think, our worst frosted crops. Was a couple of paddocks we seeded about a week and a half after we finished seeding. We seeded 2 other paddocks because we had sheep still on hand. We got rid of them and seeded the paddocks, and they were the worst frosted paddocks we had that year. So delaying seeding, I think, was a waste of time, but not putting all your eggs in one basket is one of our strategies. But yeah, so it's the more I learn about frost, the less I know, I think.
Yes, yeah. It's a common story. Thanks, Craig. We've got someone on an unnamed iPhone. If they could introduce themselves.
Hi, Tina, that's me, Helen White.
Thanks.
Sorry, I'll be up and down, so I'll save the screen to distract everyone.
Sure.
Yeah, farming out Kibowling, Wickepin Way, and also an agronomist with elders. So yeah, just looking what tools we can use and my growers can use, and yeah, seeing where we're at.
Great. And Marie, Naz.
Morning, everyone. I will also save the screen because I'm running around with my small child at home today. But yeah, I'm part of the FAHMA group team as the innovation coordinator and also part of this RiskWi project that we're running at the group. So yeah, just interested to find out what this project's all about and where we can sort of, yeah, use it in systems really. So.
Great. Thanks so much. I'll hand over to David and Julianne.
Thanks, Tina. Thanks, everyone. Yeah, and I really appreciate the introductions there. All right, and let's see if I can start the share the screen. Okay, coming. Now hold on, folks. Here we go. All right. So Tina, that's coming through okay, folks? Can you see that okay?
Yep.
Great. Yeah, so this is it's called the Frost and Heat Management Analytics Project, and we call it FAHMA for short. That's the acronym. And the main sponsor of the project is the GRDC. There are about 17 organisations, including CSIRO and GRDC, and the project participants include commercial end users, and grower groups. So we build agribusiness and elders, and there's a bunch of research partners as well, and some ag tech partners. So in this project, we really wanted to try and bring together the whole commercial and development and research, so that we could really target the needs of end users, like yourselves on the call here today. And so that's the people that we've got in the project team, if you like. And in terms of what are we trying to achieve with this project, the idea is to create these viable products that support decision making for growers, agronomists, and agribusiness based on the likely yield impacts of frost and heat. And in the remit, we've got these 5 species: wheat, barley, canola, chickpeas, and lentils. So we really are trying to help people create some tools to enable people to better manage the risks of frost and heat. And viable in the sense that we really want these products to be standing on their own 2 legs, if you like, at the end of the project, so that they can be supported and running, enduring beyond the life of the project. Just talk a little bit here around the technologies that we're bringing and the applications that we are focusing on. We've been doing some work in CSIRO on mapping the temperature at about a 30-metre scale, and we've got some satellite that help us do that, and I'll talk about that in a minute. And so we've spent a lot of time working on this temperature mapping technology that can map the overnight temperature at about 30 metres resolution. So from that, we can get an idea about how bad it was and how long it, for what temperature, so and the spatial extent, like the where. The other piece of information that we've got that can tell us the impact on the crop is the crop model, the AppSim crop model. So what we try and get from that is the yield loss. So we have our temperature and the crop model, and so we have the mapping, and then also getting a better idea about how much yield loss we have in a particular part of the paddock. We're targeting the applications that we're targeting. So, okay, seeing if we can enable people to have decisions, if you like, that are cognizant of these risks, or try and improve or support where possible, support insurance policy decisions and in-season decisions like we're talking about on the call there earlier. Where was it? How bad was it? Should we go into hay production, and whereabouts? And then the other one, finally, like if we have the technology up to a level, then to enable an insurance assessment without someone having to come out and look at it and try and make a damage assessment. It's really around, okay, we had this was the temperature over this location, and then a policy can work on that basis. So these are the high level applications that the technology and applications that we're working on. In terms of the delivery, like how are we going to bring this to life and get this into so that it makes a difference in your enterprise. The working backwards, right? If we're starting with the growers, agronomists, and end users, we've got Delta Agribusiness and Elders in the project, and the other partners that we've got are the ag tech and commercial partners. So these partners are really responsible for taking the R&D and bringing it into their platforms, into their tools, and then they work with the agronomists and growers over here. We are focused on, down the bottom right-hand corner here, is creating these data products, and these are things like temperature maps and estimates of damage from a post-event from frost and heat, and making sure that we've got improvements around optimal time of sowing and phenology. We have question marks in there because they're the ones that we're still working on, like working with the partners and agronomists to really try and define what the need is there and what they should look like. The main commercial partner that we have in the project is a company called Aerosoft, and this is a tech company. It's not an ag tech company. It's like a pure technology company, and they specialize in bringing the temperature mapping and the science workflows, if you like, and bringing in all the data and then making it available to others. So the idea is we've got to try and drive the cost of this stuff down as low as possible to get viability up. And so that's why we've gone for this model where we focus on only setting the technology up in one place, but making it available to many users, not exclusively here as data products. It can then be brought into the particular application depending on the need. In terms of so that's the delivery model. I'm going to talk a bit more around the work we've been doing on trying to map the nighttime temperature. So as I mentioned, we've got some satellite technology, and what we can do with that is we get the land surface temperature from the satellite every 10 minutes. What it does, so that's across the whole continent. So we have a resolution of 2 kilometers, a native, if you like, resolution of 2 kilometers. And in this example, we've got this is the Steer Research Farm at Borua in southern New South Wales, only about 300 hectares, but it's a good prototyping place for us. So there's close to the township of Borowa. So we have the national and the regional scale, but then we do some work here to bring it down to 30 meters resolution. And we can see here the variation in temperature, like across, you know, there's a lower lying sort of creek down here, and then this is the higher portion of the farm up here. And this is an example of the overnight minimum temperature back in July 2021. There's a couple of things that we get from this that have, that we hope will be useful, and one is we really get the frequency. So we've got every 10 minutes, and from that, like, so we're getting the severity, so how cold was it in a particular location, and then the duration, like how long was it at a particular or below a particular level. And I think, and here we've got like a below zero for the number of hours here on a particular night. So we're getting much more detailed information, if you like, both spatially and in terms of the severity and the duration. We've done we did a really solid body of work to try and test it against ground truther data, if you like. So this is going back to the Borowa research farm. This is an elevation map here. So I was talking before, there's a little bit of, it is a frost prone area. So this is that creek bed down here, and the elevation is a bit lower, and then the higher part is up here. We put these sensors down here. These sensors measure the land surface temperature, and every one of these dots is actually a sensor. And so we did the big validation exercise, and we wanted to try and understand, okay, we've got the satellite versus the ground-based sensor. Let's have a good look at that. And then the result, so at the 2 kilometers, we basically got, this is the observed and this is the satellite. It's plus or minus 1.5 degrees. And then when we downscale it at 30 meters, it's plus or minus 2 degrees. So then, yeah, that's sort of wrapping up, or the overview, if you like, of the temperature mapping technology that we've got, that we're working on. And then the next piece I'll talk about here is that like using that temperature information and the crop model to get a better indication of yield loss within the paddock. So we use the AppSim crop model. Basically what this thing does is you've got all of the inputs for for radiation, rainfall, and the information, the soil information from the crop, the species and cultivar, and temperature and so forth. And so this thing grows the crop. And this is the main basis for how we're doing this piece of work. It needs some information, so we bring in some information around the climate locally, and then the soil, and then the specific management, and then the outputs that we get. So we get the flowering time, and then the yield reduction that incorporates the frost and the heat event. So we can get like a relative % loss in the paddock, but we can get an absolute in terms of tonnes per hectare. And the whole point here is to try and support that that decision around, okay, we've had some events, and do we, is hay production whereabouts in the paddock? Should we do that? Yeah, so then we've done some work in the trying to see how well we can account for the frost and heat. And this is an example of that work with canola. And by incorporating the frost and heat across our data set, we've been able to reduce the error from nearly 50% here down to 20%. So you can see here, this is without the what we call the damage functions. And this is the observed canola, and that's the model canola. And then we improve it here at all. The idea is to try and get these things on the 1-to-1 line, on this line in the center here. So you can see we bring these things down and improve the capacity. So that just gives us we're really trying to improve how well we can do that. I think what we're really trying to do this year is really do a lot more testing and validation over this growing season with the partners that we have in the project. So we really need to, we're going to try and get these products up and get them in the hands of the ag tech companies, and then so they can work with the agronomists and yourselves, growers. Get the feedback. Is this useful? Should it look like this? What do I need to make a good decision that's going to support my enterprise? So that's what we'll be doing this year. And so in the project, this is a small example of that, a little bit of flavor, if you like. One of the companies is called Pear Tree. They specialize in bringing data around and integrating data and creating dashboards and things. And this is an example of some of the work they did last year to help us move forward. I'm going to pass over to Julianne in a minute, but one of the things that Julianne's going to speak about is the pre-season planning, and we've got a demo tool to talk about that. So we're trying to understand what the need is for this, and like how folks might be able to, how this might improve people's decision making in their enterprise. We're working with AgWorld, and thinking about how might we incorporate these tools into that platform, and reuse data that's already in that platform as well. Yeah, so this is just the high level summary of the project. And before I hand over to Julianne, so it runs from July 22 to June 26. We're really trying to create these viable products with commercial partners so that growers and agronomists can better manage the risks of frost and heat. We are targeting a release, if you like, of the temperature mapping product that I spoke of earlier in the piece, and really do some testing of that this growing season. The pre-season planning product, we've got a little bit more work to do in terms of thinking about that, but that's something that we're looking at to try and have more testing of that later in the project. And so now so that's about the FAHMA project. And another piece that we really want to get your feedback on and your thoughts on is this flower calculator. So we can talk a little bit now about the flower calculator, and how might this improve planning decisions. So I can, maybe Julianne can come off mute, and I can keep clicking the slides.
Okay. Hi everybody. So this is about the piece of work we've done where we've identified when is the best time for a crop to flower to maximize yield. So on the long-term average, what is the date that the crop should flower to reach that maximum yield? You can see in the grey bar. And we know that is basically the period when you've minimized all the stresses that damage or reduce yield. So, of course, if a crop flowers too early, there's going to be more frost damage or higher risk of frost damage, and therefore, on average, it will yield lower if it flowers at that point in time. And if it flowers late, more likely to have heat damage to the yield. And of course, water stress is a stress that just increases in our environment where we grow crops into a terminal drought. That water stress is increasing throughout the period. And we've done that analysis in this case for canola, but it's the same for other crops at those 77 different locations you can see throughout the cropping zone that are the dots on that map. Do you want to go to the next slide, Dave? Yes, and so then once we have this information, what we're wanting to do is develop a tool that can be used so that knowing your flowering time is important, but how do you understand what variety you should sow and when should you sow it, so that that your variety is going to flower in the optimal flowering period. So the APSIM models simulate phenology, but because new varieties are constantly being released, and particularly in canola, the turnover is very rapid, but also in wheat and barley, which are part of this project, we need to have new phenology parameters that predict when the flowering will occur according to the environment the crop experiences. And we need to have those phenology parameters ready for when a new variety is released. You know, if a new variety is released and growers start growing and it takes a couple of years to work out, you know, when is the best time to sow it so that it flowers at the right time, you know, that's unfortunate compared to if you already knew as the variety was released. So we've I guess that's part of this project, is to look at new phenology parameters for new cultivars, as well as developing this tool. Dave, do you want to go to the next slide? Yeah, so I guess that's kind of summarised here. In this project, we're using genetic analyses to analyse the genetic the genes that control flowering in each new cultivar and use those to predict the phenology. And then we'll be testing it against the national variety trial data. So we will have a genetic prediction. We'll check it against those varieties that are in NVT, and they are grown in NVT for the last 2 years before they're released. So we'll have that observed data to check it against. As part of this project, the aim is to have the 77 locations, which we already have in the tool that's available for testing. And the project requires 850 locations by 2025. In fact, we've already done it for wheat in about 3,800 different MET stations across the growing zone, but that's still in a sort of even more reserved testing ground at the moment, just checking we can get that workflow going for that huge number of weather stations. But then in the end, with that many locations, then you'll be able to choose somewhere that's much closer to your own property and more representative of your own paddocks. You want to go to the next slide, Dave? So I just like to show you now how this prototype flowering calculator works. So when you log on to the screen, this is the first thing you see. And there's a bit of an explanation about how it works. And then so you can select your location. So if you click on that find location, and you'll have, this is a slide, so you'll have to go to the next one, Dave. Then, you know, these locations are scattered with marks showing where we have those current weather stations, and then you can either click on one of those or use the drop down box to select one. It'll automatically go to the closest weather station to wherever you are at the time, but you know, you can either move the screen around or use the drop down to find the weather station you want. So you select that. That's a screenshot sort of showing you across Australia. And the next one, Dave. And then you choose which crop that you would like to get the information for. So you click on one of those, and I think the first example might be canola, and you have these two questions, and you'll have that question whether it's wheat, canola or barley, and that is you know what variety. The first question is that you know your intended sowing date, so you've got a plan of when you expect, you know, according to your paddock management, when you might like to sow. So you saying which variety would best suit that paddock. Or the other question is, if you've already the second one, if you've already bought your seed, so you know what variety you've got to sow, and you're asking when is the optimal time to sow that variety. So then if you click on one of those questions and then press the go button, in canola it comes up with a screen like this where you can select, you can sort of filter for a herbicide type or for a company, and then you can pick your cultivars, and then you can do similar things in wheat and barley. Dave, we might just move to the live thing now and see if we can make it work. You select, yeah, so that's the way you select a question. So shall we select somewhere near? We're doing that magic thing where Dave's doing all the work and I'm trying to match my words.
I think Corrigan is the closest one for us.
Up.
Oh.
No Corrigan there. Up and just to the east of Corrigan, shall we go?
Yeah, thank you. That'll sorry, west of Corrigan would be the closer one. What's that one to west there? What's that?
Oh, yeah. That's actually what I meant. Ah, it says Corrigan. There you go. Something funny in the. So maybe we can go to canola, Dave, and go to the when should I sow question. You know your variety, and then if you just show the herbicide drop down menu. So that's, you can pick these different herbicides. So let's just pick TT, and then you can show us all companies. I'm not sure how many we have. Yeah, we have a few. Maybe we won't select one. And then if you click in there, then you can get different varieties that you could choose. So maybe, I don't know, do you want to put Bonito and Wahoo? Because I think they'll be different. And you can choose up to 3. They're not very different here. But so what this shows you is the vertical blue band is the optimal flowering period. And so depending on these different sowing dates as you go down, for each of them, it's predicting when would the crop flower if you sowed it then. And you can see for those varieties, you'd be wanting to sow it between the 5th and 12th of April, basically, in the week starting the 5th or the week starting the 12th of April, is what the prediction is. For canola, because the varieties turn over so rapidly, we only have old varieties in the tool from work we did prior to 2019. And in the new project, we're now doing the genotyping now to get the up-to-date varieties. Shall we move to wheat, Dave? Mm-hmm. I think we can. So, you know, that's a current flaw with it, that we don't have up-to-date canola varieties. We only have old ones. But that's part of the goal of the project. Maybe we'll do the other question.
Yep.
So I don't know what week you'd like. Shall we, 26th of April, pick that. And then what this version shows you is all the wheat cultivars we have in the system. And if you sowed on the 26th of April, when we predict each of them would flower. So there's a diamond, and the date just above it shows the average flowering date. And if you hover over one of those little dots on the left-hand side or the right, you get the earliest it has flowered in the last 60 years and the latest it's flowered in the last 60 years, according to the model with that sowing date. So, and ideally what you want is your whole diamond to be in that vertical bar. So that suggests that those varieties from about Derrimut down, or maybe even Marinda down. We don't have any filters in the wheat yet, and the list is far too long, so it makes it a bit cumbersome, but we are going to put some filters in. We're thinking of, based on what the NVT declares the company that produced the cultivar, and whether it's prime hard or, you know, what the classification of the wheat variety is. I know they don't always make that grade, but it's, you know, the classification that's given in the NVT data set. So, yeah, Dave, do you want to just go to the other question with wheat? So when you go back, you just click on the, yeah, just click on wheat flowering calculator up the top, Dave. Yep, there. And then go to wheat again and that question. And I know if you put Axe and Bennett and Bolak, you get, that sort of gives you more of a picture of, you know, 3 different cultivars that have a different fit or lack of fit. At in the case of Bennett, Bennett's too slow for your location. So I think that's, yeah, all that data there appears in a table further down. So if you prefer it as numbers, they're listed, it's all listed there. And the optimal flowering period appears further up in that yellowy box right at the top.
Yeah. In
the orange box, yeah. So that is the start and the end of that vertical blue bar. So I guess if you have your own experience and you really think that that's not quite right, or it's a bit later because you've got a paddock that's very prone to frost, then you might want to your crop to actually flower in the later part of the window. If you've got a paddock that's not at all prone to frost, you can probably reduce your risk of heat stress by, you know, flowering a little bit earlier. So,
yep, great. I think that's, yeah, that's the slides that we kind of had. And yeah, like I think now it's really open to feedback and discussion, and yeah, your initial thoughts and comments around this, and particularly around your interests, and we can definitely open up, yeah, like we're keen to hear what people think. Stop sharing.
Julian, it's Craig Jesperson here.
Yeah.
Just one, it's not important, but it's one thing I'd with the sowing dates, I always find it. I think it should be listed as germination date, because you can be growing canola and you want to put it in first week of April. If it doesn't rain till the middle of June, it's
it's June. It counts.
But yeah, it depends on when it's going to rain. But yeah, you got to guess that anyway. So it's when you're picking your varieties, or you got to have a host of different varieties, so you've got that up your sleeve as to your decision making, what you want to do.
Yeah, you are right, and all the calculations are actually based on germination date, but they're I have to check whether we've back calculated to like a sowing date as if it came straight up. But we could if you think it's a better way to describe the tool, we could refer to germination date. I guess it's just your actual action is sowing.
Yeah, I understand that.
So
The hardest, yeah, it's whether, because you know the delay. You know, some crops come up in 3 days, and some take 7, 8, 10 days. So it's all, yeah.
Yes, I agree.
But
It's also, I also think, there's sowing, and then unfortunately get those damn dry starts, which are then unpredictable when it's going to come up, isn't it? So to Craig's other point, and it just throws us out of the window a bit. Out of the thing, and it's horrible to say, but frost will still happen. So what's the project doing, I guess, to look at ways of when it does occur? So some of that mapping stuff you showed was really good, and obviously gives good clues as to where management might need to be altered or make the most out of the bad situation. Like, is this sort of work in this project to get to that point too? I think, David, you might have sort of alluded to that. That was sort of a focus.
Yeah. So they've like really been able to map where the for mapping temperature across the landscape, so that folks can really know where to go, where to look, and to I guess really delineate where the damage is. So the first step in that is the temperature mapping work, and then which we're trying to get that up and running so that people can test that this year. And then the next sort of building on top of that is, okay, what is the impact of the temperature, the frost on the actual crop? That's what which is, the damage sort of,
I think those satellites at the moment, they certainly help to really get down to those areas that are worth going for an extra look. But that obviously means driving, riding the motorbike, walking, or whatever. I think we're working on some projects. It's not for frost specifically, but my brain was going into all sorts of thoughts as you were talking about the technology that we may be able to apply that. Like, we're looking at weed control specifically, but even down to the ability that once you can zoom or home in a bit more on where to then put more technology. Someone mentioned drones before, or some sort of ultra high res imaging. And being able to focus on that to say that is, and therefore I've got decisions to make. I mean, all the growers on here, you'd all be doing that, but obviously with scale and all that sort of stuff, getting over everything and making that call. There's a bit of intuition, but the tools are probably getting better and better, and there's probably going to be more and more ability to build an algorithm or something that can identify and say that's definitely a frost impact compared to when I was working on it 30 years ago, 20 or 30. We just didn't have that power.
Yep. So the resolution that we're chasing is like looking at a 30-meter resolution map, and so trying to have that like ready that the morning of, in terms of this is the map, and this is where it was worst, and then eventually like the sort of the map of, I guess, the percent reduction in production and yield.
I think that would give great clues and insights to then either deploy another technology to maybe get over more scale and then be able to hit the trigger. Unfortunately, they will still happen. How can you make the most out of it? Gary probably knows what I'm banging on about, and other guys. If John Hicks was here.
Yeah, Craig, just a little bit. There's a lot of talk about the cutting of crops. I've never been terribly excited about that in the West, because we have such large-scale frost events that and zero and very small livestock numbers and getting less. So it's not like where I've been over east, and every farm has a hay shed, and they fill a big hay shed, and they fill it up with fodder and wait for the next Queensland cattle drought and sell it all off. We just don't have that option in the West. If we could cut it early enough, there's potential to export it, but that has never really happened. But that would be my feeling on the cutting. There's a lot of talk today about the cutting and whatever. It's more an eastern states thing than a west thing. The cutting, I would have thought. But I am interested that the temp mapping, I think, is really interesting for pre-season planning, and to really understand your farm. We all know where the cold areas are on our farms, but we don't have any data around that. And we could do better with the data that the temp mapping over periods of time would give us. So, yeah, really excited about that.
Mm.
Also, Dave, wondering... Sorry, go on. Someone else was going.
No, sorry, go on. Yeah.
You did state that you were hoping to roll that out in 2024. How would producers get access to sort of maybe a beta version or sort of a trial version of that, David?
Yeah, it's a real balance. Like, we've got to sort of do some testing, but like just within the I guess the bandwidth of the project and what we can do. I just wanted to tease that about in a bit more, like around we haven't had a lot of conversation around the use of the temperature information to support the pre-season. Like, yeah, we talked all about pre-season just with the demo before, but it'd be good to get some more ideas around what it might look like from your perspective.
Any of the other farmers? Or?
Yeah. Oh, sorry. Yeah, go ahead. I've got a thought about it, but just wait.
Well, it just whether the extent to which paddocks are getting cold will dictate your management strategy. Be it a later flowering date, it shifts that balance of shifts that blue band in the flowering calculator, shifts that to the right if it's a particularly cold, or a fair chunk of the paddock's particularly cold. So that's really how it works. And so you can either have a longer season cultivar or a different crop, being in our case wheat. We'd replace barley with wheat with barley or oats, and that's kind of the advantage of temp mapping, but which we all do now in this district, but we would do with a little more accuracy with the temp mapping, basically.
How historical, like how far can you bring these in, from a lot of years?
Yeah. So at the moment, that satellite record started in 2015. So we've got that. Yeah. So we go back to, the winter of 2015 to today. So it's not a huge record, right? Just, short of 10 years. In the first instance.
I guess, that builds. Sorry, David.
Yeah, you're right. No, I mean, there'd be another body of work if we really wanted to try and extend it back somehow, or like do some other work to try and use the, existing information. But historical, what's sort of feasible is that 10-year record. Yeah.
Something like with management and growers on the call, it'd be interesting to hear what you think. Would you change your management in terms of inputs going into it? So if you had 5 years of history, and I'm thinking we do things like fungicide response, building those up over the years, and therefore there's parts of paddocks that just don't make sense to put the top fungicide in, or any at all, year after year after year, as opposed to a blanket. Would you change if you had that knowledge, or are you still going to try and go for broke everywhere? Not broke, go for the best every year. You want to do that, but I used to say when I was in the Frost project, the profitability over productivity, which sounds a bit daft, but all it was really trying to say is just areas that consistently don't perform, or have such high risk, that then you go and put all the inputs, expensive chemicals and things like that in there. The technology ability to be able to tailor that a lot more. Would you do that? Gary, I know you, and I know you'd have a comment probably, but can I lob you into would you do that? If these maps could show.
To some degree. I'm hoping others will comment. I've done that for a while, crazy you do that, I know.
Yeah.
Yeah, I'm sure most farmers, Helen, you guys would plant oats
instead
where appropriate, and frost risk would be a big part of that. So
definitely, and I think it's possibly, and Craig and Andrew both alluded to it, it's those areas that don't follow the usual pattern. So they're not the ones necessarily the lowest in the landscape, but they always get frosted. It's probably identifying some of those spots where maybe we've got the most to gain.
Okay, they're not. Yeah, they're not super obvious ones.
Yeah.
Places.
Yeah.
It's the old data versus observation and intuition.
Yeah. Well, that's important, very important. Yeah, that's what you're saying.
Yeah, the more data you have, the better chance you've got of making the correct decision, or it just backs up the decisions you are making. Or you might actually find that some paddocks you think are more frost prone than another. You actually realise the area actually isn't quite as big, because when you go into a frosted patch, it looks a lot bigger than when you walk out of it, and it's just trying to map that. Sometimes it doesn't run to soil types. It's not. Sometimes it is, and other years it's not. It's all just germination timing and that. I've found some years it's a heavy country gets frosted and the light stuff's okay. It's just all in the timing of when it happened and the severity of it. But the more data you can get, the more information you can make an educated guess.
I just want to make sure you saw, I think, Helen's question in the chat box.
The first question?
Yeah, so can you view the frost heat risk profile?
Yeah, I was just typing an answer to it, but it's better to speak to it. So you can't see that risk profile. Because of how it's set up, it's a database, and that we would not be able to incorporate that sort of complex a piece of data for a location there. And I think that, like, if you're thinking about like a rare late frost, I know they don't feel that rare when they happen, but if you had a -4 degree event or something that was quite a bit later than normal, and then you compared it against these are against a 60-year record. So that -4 that occurred once in 60 years, it's not going to show up, in that long-term average anyway. So I think that you won't really see them. You'll see a very smooth shape that gives you that optimal flowering period. What you would see is how rapid the descent into it is or out, but I think that's probably also indicated by a broad bar. So if it's a really sharp narrow window for optimal flowering period, then it's likely to have frosts that come very close to the start of the optimal flowering period, and heat that there's an onset really quickly. As we have different environments all over the country, and some of them are much softer, much less at risk of frost or heat or both, and others can be slammed by both very easily, and they're just more risky.
So is there a definition of what that bar represents, Julianne?
Yeah, so it is that if I could share that first slide again. It's when the simulated yield is the top 10% of simulated yields. So let me just share it. I can't share. Dave will have to share it.
Yep. So
it's probably the first flowering slide. Yeah, this one. So the black line is the APSIM simulated yield when the damage functions are applied. So basically, and the x-axis is the date of flowering. This was generated for canola, so it's called start of flowering, but the same principle holds for cereals. So if you flowered right at the beginning of that window, then the frost stress is very high and the yield is very low relative to the maximum. And then the later you flower, the higher the yield. And then at the back end, as heat stress starts to kick in, yield is reduced more and more the later the crop flowers. So the grey bar is basically set by finding the maximum yield on that black line and then keeping within 10% of that yield, so no more than 10% reduction.
Yeah.
And, you know, it kind of goes to the extreme, like at the extreme left and the extreme right, we have simulated yields, but you're unlikely to have actually done that yourself. But, you know, unless perhaps, you know, there was a dry sowing and a very late germination, very late emergence might, you know, result in a very late flowering crop, or a misunderstanding of the flowering behavior of the particular crop that you sowed, and that, you know, you sow it early and then it races up to flower and you end up with one of those yields at the extreme left of the figure. So if you're a little bit outside the optimal period, then on a 60-year average, you'll get more than a greater than 10% yield reduction. And what you get in the particular year you do it, well, that's, you know, that's the variation we deal with in the Australian climate. But yeah, so this is based on long-term average.
I mainly asked that question too, because like I like seeing that graph where you can see the frost and the heat for the location. Doesn't necessarily have to be in conjunction with the optimal sowing data, because I understand that would be hard to overlay. But yeah, and as much just to see how far we're pushing into that heat stress window. Yeah. So that's just why I asked, because I know they took that off the old flower power, and I found that frustrating. But that's just my feedback.
Yes, well, we certainly do have them, because that's how we have determined the optimal flowering period for like the 3,800 weather stations we've just done. We've basically, you know, drawn these figures for all of them.
So Julianne, David, the damage functions in that APSIM, they're calculated from National Phenology 1 project. Is that correct? And or do you have any more actual trials going into shore up that damage functions?
So the damage functions, that they're not from the National Phenology 1 project. They're from other research investments. The canola ones come from the optimizing canola productivity project, and then we've been working on them since, and we've been working on the wheat, and the very original canola and wheat ones come from a dual purpose cropping project. But we are currently in the project working on collecting data from our research partners, so the state the state departments mainly, like DPIRD and New South Wales Department and SARDI, and using their data to cross-check against the functions that we've developed and then improve them a little bit, like try and make them a little bit better. And then, so we're using existing data rather than our own experiments. And then, but we are working to now to obtain some more field data to do an independent validation of them. So we're just talking about that with some consultant organisations at the moment. And that'll be an activity we try to do this year.
Right. The optimising canola project only did 5 things in Western Australia. By the side, as I understood.
The optimising canola project actually wasn't in Western Australia, but those 77 were done. So there's in that project. So we did do it nationally, and talked with people in other, other researchers. Yeah, so there's, I think, look, I forget, there's 18 or 20 in Western Australia, something like that, in that 77.
Yep. I'll talk to you about that another day.
Yeah, okay. Happy to do that.
My other question was on the comparing on the flower powering thing. I wondered if you can compare wheat and barley varieties, whether you should be sowing wheat or barley at a certain date.
Yes, because you mean we've separated the crops. You're either looking at wheat or you're looking at barley, so you're going to have a notepad and make a whole lot of notes.
We wouldn't do that. We would substitute one for the other as a frost risk management.
Yeah, I understand that you're basically having to do a whole lot of note taking to do your comparison. Is what you're saying. Yep, we can. That's a good bit of feedback. We could have a think about whether there's a way to do that. I think in this tool we probably wouldn't, but perhaps the ag tech companies might design something a little bit different that makes use of that same data, and they might in their, like their farm planning use of this information from this project, they may very well do something like that. But still, I'll talk about it with the other people in the project, and we'll have a chat about whether we should combine wheat and barley, and we could then make it one of those filters, I guess, because what you've just suggested made the list a whole lot longer.
The other bit I had here was screening west versus east varieties. I mean, there's varieties you can't deliver in the west, or the ones starting with sun.
Yep. Okay.
Can't or don't. I'm not sure which. Helen would know. But
yeah, so that's something for the software, like just for us to put to the software builders.
Yep.
Can we add a couple more filters? Can we add this filter, that filter?
I think if you're going off the NVTs, that should filter them anyway, but I agree that would cut the field in half pretty quickly, which would make it a bit simpler to look at.
Yeah. Would you find a quality filter useful? Like, whether it's APA, like you've got your different categories of wheat. Would that be useful to you or not really?
Not really, because growers don't tend to select varieties on that. For noodle wheats, possibly. But yeah, most growers are going for higher yield and not so worried about growing specifically a hard or
What planning tools are people using now?
For variety selection or sowing date, or
the whole thing, the whole process.
Yeah, so variety selection, obviously your NVTs and just your yield data, looking at yield primarily. Sowing date, like the old flower power was used a little bit, but now it's probably more gut feel, and it really comes back to program size. And like Craig was saying, we're just spreading our risk, so making sure we're not sowing all of the same thing at once. And by the time we get through sort of our canola program and we've got a spread of dates, yeah. So no specific program as such.
Yeah. So like just experience, right? And understanding of the system.
Yeah, and then paddocks. So certain paddocks won't go into certain crops, like Gary was saying, and then just sort of overlaying all of that rotations. Yep.
So many people using like some of the existing, so for example, the farm management software tools that are out there now to
so we're using AgWorld, both on farm and obviously through elders, and a lot of people using that, but probably that's rotational based, and then putting in our varieties as opposed to looking at seeding dates. Probably more comes from rotational and hectares and programs rather than seeders. We don't really put a specific seeding date in there, just because every season is completely different, and as I was saying, germination time versus seeding time will vary. So it's more about which crops will get sown first than what specific seeding date any variety will get sown.
Yeah. And so when in the process is that interaction with the AgWorld system, is that sort of happening before the event, before sowing, or during, or after? What's the
so planning now.
Yeah.
Planning now, and looking at varieties and
The bolt-on system to AgWorld and other things is a really good idea. Just chances of getting growers to open up another tool is minimal.
Yeah, a lot of friction there with that.
Yep.
Makes sense.
Oh, it's just time pressure.
Yep.
It's time pressure.
Yep.
I've always personally just used a spreadsheet and just done a spreadsheet. We'll say these paddocks this week, these paddocks next week, and have a plan when you start the year, and it all goes pear-shaped after about a week and a half, and you just keep changing the plan till you get finished.
Yeah, so David, the way I've used selected varieties over time has just been through NVTs, agronomist advice, having a range, bit of a range of different, a couple of barleys and a couple of wheats, and keeping enough so that if it's a late, if we know we've got no subsoil moisture, we'll keep some, grow shorter season varieties. We'll put more of that in. But if we've got an early start, we'll put more longer season varieties in. But we'll do a mix and hedge our bets. So it's just a sort of talking to different people and different farmers, and what varieties are, some are more flexible in dry seasons or short seasons or long seasons. They can, so we just try and hedge our bets, and whether they've got, a bit better frost tolerance or not. Yes, we used to grow a lot of wild catch 'em, and then we found out it was frost catch 'em. So, those kind of varieties get thrown out fairly quick, and ones that can adapt a bit more and don't get affected quite as much by frost, or they can, a bit more flexible in the growing season, seem to be the ones that become more popular and we grow. So it's, yeah, different. Everyone's the same, I dare say, where they they pick varieties.
Has any of the growers here had any experience with shandies where you have two varieties in the one paddock?
We've done a little bit of it. We're actually going to do a bit more this year. Past part's just getting a decent shandy mix, so it doesn't you don't get the banding effect in your air seeder, so you get stripes in your paddock, and you can see different colours and different varieties. I think Garrinell did a trial many years ago doing frost research, and I think Garrin found there wasn't much difference in shanding as to whether you planted one paddock in a variety and the paddock next door to it into a different variety, or you shandied them. That didn't make much difference, but it all depends on the lay of the land, I guess, and how the season runs. You need to do it over a number of years. I know there's a few guys that all do it, and it's just a tool to mitigate frost risk. Have you done it at all, Gary? I think you need to unmute, Gary.
There we go. Sorry. Pretty definite. No, I have never done it, or I don't think I've ever done it actually. The data out of the NFI was pretty strong that we didn't get a benefit doing it all over the place for 3 years in a row. So yeah, so I've never done it. No.
Okay. Some really useful feedback discussion here.
Do we have any last questions, I suppose? We've gone a little over time. I really appreciate everyone putting the effort into attending this morning.
Just, David, how long before, is it another couple of years before there's, farmers will get access to the satellite temperature maps, or when?
Yeah, so we want to, so we have a beta version that's available now, but that's just within the project. And so some of the ag tech companies that are partners in the project have been using it and testing it. And we've had a few problems with it, and we're working on a fix. And so that we're wanting that to be available for testing this growing season. And yeah, if that all goes well, then it's like then that's sort of sooner rather than later. But it's pretty hard to put a date on it in terms of when it will be available commercially outside of the project, other than to say, like, we're really aiming, I suppose we're aiming for like, I guess 18 months type thing is really what we're aiming for. And I think we have to sort of come back and, I guess, give an update about where we're up to in sort of 6 months' time. We'll know a lot more after this growing season when we do the testing with thing. And I mean, one of the tests is companies that we're involved in is elders. So Helen, I mean, that might also be something interesting, Helen, if within the company there, we could even talk about the possibility of what your involvement there might look like, because you're working with some of the team here. We could, like, in terms of testing, if you had capacity, because we've got the elders are part of the project, so we can support that. If that sounded useful.
Yep, happy to help wherever I can.
Okay. Great. Well, maybe that's a little starting point if we if we just talk offline to just have a bit more of or maybe Tina, if you can just share Helen's details and we can follow up after. It'd be great.
Yep.
Okay, so I think we will leave it at that point today if we don't have anything further. I'd really like to thank Julianne and David for sharing the details of the project this morning. I'd also like to thank GRDC and CSIRO for their ongoing commitment to research in this area. As you can tell, it is an important focus for our producers. I'll get Helen in contact with you, David, for further work there. A beta tester in Western Australia would be a fantastic idea, and our region